will be very informal. I think we'll have a short presentation, and then that will follow up with discussion. So we'll have a lots of discussion by the end of the session. So without further ado, Dr. Juan Pinero, if you can take it away. So just to give you a brief background on the audience. So this is our group of audience for the AG2PI training program. So basically we have students from different universities. We have at least 3 universities here: Texas A&M University in College Station. We have Texas A&M in Kingsville and Texas A&M Corpus Christi. And these students, they come from different background as well. We have a couple of students from animal science background. We have few from crop science, and we have some computer science and database and wide range of backgrounds. So I think they will benefit more from a discussion from a layman perspective, where we talk to some people without any animal science background. So I think that's pretty much of the audience. And I didn't see our. Okay, Dr. Lucy is not here, so Dr. Vandari, me, and Dr. Lucy, 3 of us, we coordinate these sessions and have guests come and talk to us about like data, how to manage data from crop science perspective and animal science perspective. Okay.
Awesome.
Over to you.
Yeah, thanks a lot for the invite and for the introduction, Sushil, and hello everybody. How are you doing today?
Very good.
I must admit I'm a little bit jealous from you all, especially the ones that are in Corpus Christi, because you're close to the beach, and I'm in Amarillo, super dry here and hot, and I think that the closest lake is very small and is 1.5 hours away. So
yeah, and anyway, you are missing the humidity too.
Yeah, yeah, it is quite dry here. But yeah, as Sushil said, I'm an extension dairy specialist, so I work quite a lot with dairy farmers. So I'll be trying to cover some more practical aspects. But if you have some questions about general aspects of precision technologies, feel free to stop me at any time. And let's try to make this interactive. I mean, it's very informal. It would be more funny if you stop me at any time, just unmute yourself and ask questions. And I'll probably will ask you questions to keep you engaged. And I'll start sharing my screen now. Let's see.
And one more thing, Dr. Pinero. So we would like to record this session. I already started the recording. And this recording will go kind of, it will be public as well. So I hope it doesn't matter to you.
That's okay. That's completely fine. Anyways, let's see. Start sharing this one. And let me open the PowerPoint. And okay, let's put on view slideshow from the beginning. Yeah, I don't think that's the right screen that is showing. It's showing the other screen probably, right? The one that you can see the next slide.
Yeah, you can do that display setting over there and swap the monitor setting.
Okay.
On the top.
On the top, display settings.
Yeah, that top one.
This one?
That's it.
Oh, there we go. Thank you. So basically, some of these precision technologies that we use, some of them are what we could call wearable precision technologies that we have on the cow. Some other ones may be on other equipment that are not necessarily with the cow, such as milking equipment, right? But basically, they give objective, precise measures 24/7 of cows, and from wearable technologies, we have some that are ear-based, neck-based, leg-based, and mostly we use it in dairy farms for heat detection and identifying sick cows. There's some research that has been done also to try to ID cows close to calving, but it's not being used as much for this purpose. And the measures, what they measure, some of these, especially the leg base and the neck-based technologies, they have 3D accelerometers, so they can measure the activity. The leg-based technologies, especially, they can also, some of them, they can measure lying and standing time. The ear-based technologies, they can measure feeding time. Cows have different patterns of how they move ears when they are eating, and also when they are ruminating. So ear-based technologies also can measure rumination time. There's some discussion on how accurate they are, but because they are based on movement of the ears, which vary depending on if they are eating or ruminating. These ear-based technology, some of them also measure temperature as well. And with regards to neck-based technologies, we have activity and rumination mostly. So some considerations, I don't know if you guys discussed this already. If you did, let me know and I can move to the next slide. But for producers, before investing in these technologies, is of course always how much they cost, what is the warranty, the maintenance that they may have, the benefits, how many uses can we give to that technology, if it will only measure activity, or if it will measure activity and rumination, or if it will measure all of that and also temperature. The quality of the technical service, if they are close by or if they are far away, not only with wearable precision technologies, but with automatic milking systems. I see some dairy farmers that they don't get the technical service that they wish they will have. So this is quite important, knowing the distance from their dairy farm operation to the closest technical service and the availability of their personnel. The performance of the technology, we will be talking about what is sensitivity and what is specificity, and if there's peer-reviewed research and third-party validation of these technologies, basically to see their performance. Are you guys familiarized with these two concepts, sensitivity and specificity? Okay, I will take.
Maybe you can explain a little. Yeah.
Take that as a no, but basically sensitivity is the ability of these tools that we use to ID animals that may be in heat or sick, to correctly identify those cows with the event. Okay, so let's say we are using a wearable precision technology, for instance, a collar, to identify cows that may be sick or not sick. Okay, and then we can identify them as positive if basically the alarm system is flagging that cow as being sick, or negative, right? So basically what we will have, if the alarm system ID the cows as being needs to be checked because she might be sick, and she actually is sick, we will have the true positives. If the alarm system says that the cow may be sick, but she's not sick, we will have the false positives. If the alarm system flags the cow as being negative, so basically suggests to not check the cow for disease, but she was sick, we will have the false negative cows. And basically, if we get a negative flag from the alarm system and the cow was not sick, we will have the true negatives, right? So basically, we want to, of course, minimize the amount of false negative and false positives. So going back to the definition of sensitivities, from the population of sick cows is the ability to correctly identify those cows that were with the event. So is the formula is the true positive divided by the true positive plus the false negative. And because this formula is on a percent, is expressed on a percentage basis, we multiply by 100. To give example with numbers, if we have a population of 200 cows, 100 cows that are sick and 100 cows that are not sick, and basically the system, from the population of cows that are sick, the system correctly identified 85 of them as positive and are flagged positive by the system. and 15 that were sick are flagged as negative, then the sensitivity will be 85%. Does that make sense? Do you guys have any questions so far? Then I will assume that was clear as mud, hopefully. Then specificity is the ability to correctly identify cows without the event. Okay. So going back to the previous examples, here now we're going to focus on the non-sick population. And the formula now is the true negative. So these cows right here divided by the true negative plus the false positives. And of course, the smaller this number, the smaller the false positives that we have, the higher the specificity will be. Okay. So basically, if we have 90 cows that were flagged negative and were not sick, and 10 cows that were flagged as positive. Sorry, go ahead.
So I'm having one question about the true positive and false negative. You're denoting whether cow is sick or not. So like based on this data, so are you trying to those data, do you do some kind of prediction out of it?
That's correct. So basically, I was going to explain a little bit better in the following slides, but positive could be a cow that basically she decreased eating time, she decreased rumination, and she decreased steps. And that decrease in activity and decrease on eating behavior, it might be because she's getting sick. So most software, what they will do is they will combine all these individual parameters into a formula, and they develop an index, and through some statistical analysis that they find what is the perfect cut point for that index. So let's say they say it's 85 arbitrary units, and they say, okay, when it's below 85, this index that combines the activity and the feeding of the cow is because the cow might be getting sick. And if it is above 85, she's not getting sick. So that's how the alarm system works. And I'm going to show more examples in the next few slides. And those cows might or might not be sick. Did I answer your question?
Yeah, perfectly. So yeah, so I was just trying to understand, because this is the confusion matrix what you are explaining. So I just trying to understand, like, yeah, like what is the implementation out of it.
Yeah. So basically, if you're going to invest on these technologies, if you see that they have a say 50% sensitivity and 50% specificity, then it's probably a technology that you don't want to invest on because you don't trust much. But if it has over say 90% sensitivity and 90% specificity, then you know that the performance is much better.
Sounds perfect. Thank you, sir.
You're welcome. So in this example, the alarm system identified on the non-sick population of cows, 10 cows were identified as positive, so as that they might have a disease. So this will give us a specificity of 90%. And of course, we want, again, this number of false positives and false negative to be as small as possible. If we will have this number here be 1, and we will have 99 cows here, the specificity will be 99%. So that's why these parameters matter so much. So what events can we identify with wearable precision technologies? We can identify cows that are in heat. Basically, cows have a estrus behavior every 21 days on average. And during this time, they become more active. They start mounting themselves. They start walking more. They group into what we call sexually active groups, and they decrease their intake. So how many animal scientists do we have here in the audience? I know we have Kim, Esther Kim. Do we have any more? Let me ask you this question, especially to animal scientists. What will happen to cows that go in heat with regards to feeding time, rumination, and milk yield. What do you think will happen here? So here's the answer. Basically, when they go in heat, they will decrease feeding time, decrease rumination, and decrease milk yield. This will be a consequence of decreased feeding time, right? Basically, if they eat more, they will eat less, sorry, they will produce less. And this is again because they are more occupied, having this behavior with the sexually active groups. They are mounting themselves and they are decreasing the eating time. Because they are in these groups, they increase the amount of steps, they increase the standing time, and then decrease the lying bouts. What we call lying bouts is the transition from lying to standing up. And the temperature does not vary. Okay, guys, I want you to participate a little bit more. What will happen with disease with regards to feeding time, rumination, and milk yield? What happens to you when you get sick? Do you feel like eating?
No.
No. So what will happen with feeding time?
Decrease.
It will decrease, rumination as well, and milk yield will decrease as well. How about with steps and standing time?
Yes.
It will decrease as well. They will spend more time lying down. They will be less active. And they will also have less transition from lying down and standing. And the temperature will increase, right? Especially with diseases that cause systemic inflammation. They will have what we call hyperthermia, so temperature that is above the normal temperature for the species, and febrile syndrome. They will have fever, basically. For calving, they also decrease feeding time, rumination. They increase the pace. We'll be talking about that later. They increase standing time. And here's a slight difference with lying bouts. They increase the transition from lying down to standing. And that is because of the abdominal contractions prior to parturition that they have. They make the cow uncomfortable, and that's why we see this behavior that is very characteristic from cows that are close to calving. Okay? And they also have a slight drop of body temperature. So as you can see, some of these patterns repeat between these different events that happen at the cow level, and some have differences, right? So this is something that we can start to use to differentiate cows. When we build these algorithms, when we build these indexes, if we are measuring with an accelerometer, the steps, the standing time, but we are also measuring feeding and rumination and milk yield, basically we can use some of these behavioral clues so that when we build the index, we can differentiate a heat event from a disease event. Right? So basically, even though we will have, for both cows that are in heat and disease, they will have decreased feeding time, decreased milk yield. The cows that get sick will have decreased activity, where the ones that are in heat, they will have increased activity, okay? For calving, it will be a little bit easier because we are talking about a different group of cows. So basically, cows that we are trying to see if they are close to calving, they are called dry cows, or they are non-lactating. So they will be in a different group, and we have that information in the system that could be also used in the formula. But one characteristic is that they increase their lying bouts. Okay, now I'm gonna test if you guys were paying attention. So we have here some behavioral changes that occur because of cow level factors, right? So I'm trying to differentiate what we do at the herd level. So a herd level factor would be if I don't know, restrain the cows for 5 hours a day so that they are standing up. And a cow level factor would be something that is intrinsic intrinsic for the cow, such as if she gets sick or if she's in heat. And in this graph, you have on the y-axis the change in the behavior, and you have the green line is activity, and you can see a spike, and there's a decrease in rumination. So, and if you see this interval is roughly 21 days. So what is this graph showing here in this spike and in this spike of activity? Which behavior?
When the cow's in heat?
Yeah, when the cow is in heat. Good job. Okay, so in this graph, we have line time on the y-axis, and the brown line is prepartum cows, and the blue one is prepartum heifers. So the first thing you can see is that there's a difference on age, if you will, or on lactation. And older cows basically will have increased line time compared to heifers, roughly 1 hour more. But the second thing you can see in this graph is that as we approach calving, that is their day 0 here, they have the decreased line time. So I already gave you the answer, but what physiological event is this? So it's parturition, right? And we see a 1 to 2 hours line time decrease and this restless behavior that is typical of cows that are close to calving. This is, yeah, go ahead, sorry.
Maybe you need to explain a little bit on parturition.
Come
Yeah,
again?
so, so for the non-animal science audience, parturition is another term we use for calving. So it's the same thing. If the calf is kind of delivery for humans, right? So it's a period when the cow gives birth to a calf. So basically, that's the term. It's a technical term we use for calving.
Yes, I apologize for that, but yeah, basically they have this restless behavior. This is quite an intrinsic behavior from all bovines. If you go to a ranch, they walk a lot, they get away from the herd, they try to hide. They believe that that is to hide from predators. So if they have trees or they have very high bushes, they will go there to try to hide the calf so that it's not attacked by predators. So we use all these behaviors to try to have better management of the cows and know when they are going to calve, just in case if they need assistance and if they need help for a difficult delivery. So as I mentioned before, the steps also increase. What you see in the y-axis is daily steps. And you can see here that heifers walk almost 200 more steps than cows. That is quite normal as well. But the second thing that you can see in this graph is that as we approach calving, they increase the amount of steps almost by 100%, right? They duplicate the amount of steps they walk. So of course, this is also used for the formula. And with regards to the transitions, again, they think when they are close to calving, they are going to deliver this calf. They have a lot of uterine contractions combined with abdominal contractions. So they are uncomfortable, so they are standing up and lying down a lot. And you can see in this graph that they increase these transitions from roughly 10 a day to almost 17 a day. Okay. So an example of a formula that is used for this is one that my mentor developed in Ohio State, that he will have an index for predicting calving, and that index will be equal to the amount of steps divided by line time times line bouts square. Why did he have line bouts square? Because this number is quite small, so he made it a square to have a bigger number. And with that, he developed a formula, an index that will combine all these changes in behavior to try to predict. And then above a certain limit, the cow will be flagged as that she will be close to approach calving. Does this make sense so far? How this behaviors are used and how they combine all these parameters to develop these formulas or these algorithms?
I think one of the groups, they are in fact working with cow data, similar kind of data like lying time and standing time, transition up and down. And I think one thing that may be confusing to them right now that I want to explain here is like this days relative to calving. If you consider most of the data we have, that's we also call like days in milk. It's DIM or days in milk. It's similar to days relative to calving, right? So anytime a cow calves, that's a 0, and we start the count from 0, and we move ahead and we go forward. So that's basically how many days she has been since she calved. So that's days in milk. And when we want to evaluate what happened, let's say 10 days before the cow calf or delivered, that's where we give those negative numbers. So those are days, relative days to calving. So that's one thing. And I think I also explained this in our introductory session. So for those who are still confused about what are cows and heifers, so heifers, like, because most of these graphs you have like two line graphs, and I just wanted to put a note in here. So heifers are those calves that have not yet calved, right? So basically these are before calving, first lactation animals, and cows are first, maybe I don't know how you define it here, but those are generally second lactation and above. So those we consider to be cows. First lactation animals, these are considered heifers, right? So that's the standard definition if you want to compare these two lines over here in the graph.
Yeah. Yeah, you're exactly right. So the way I defined them was prior to calving or prior to day 0. So as Sushil said, heifers are female bovines that didn't go through calving. So after day 0, when they have their first calf, they will become cows. So here, heifers will change their name to first lactation cows after day 0 here. But before day 0, which will be before calving, would be called heifers. And these cows will be, basically all cows prepartum. Basically, they might have had 1, 2, 3, 4 or more calves, and here after day 0, they will add one more lactation. But yeah, if you guys have any questions at any point, please feel free to stop me. Okay, now in this graph, what you are seeing is line time, and in the y-axis you have minutes per day. So basically 600 minutes will be 10 hours right here. And these lines are locomotion score. So basically the blue line is cows that were sound, basically that will walk normally. The green line, that is locomotion score 2, will be cows that were mildly lame, and locomotion score 3 would be severely lame. So what can you see in this graph? What are you guys seeing? This difference between the red line and the other two ones? Is this a higher, do cows that have a severe lameness spend more time lying down or less time lying down than cows that are not lame or are only mildly lame?
More time.
More time, right? Roughly, we have almost hour and a half more. So basically, this is another behavioral change that is due to a cow level factor, and we call this pathological because it's due to a disease, right? The symptom that we see is that the cow is lame, but the disease might be because she has an infection in the hoof or some trauma or whatever pathology is making her have some pain. Then we have other type of pathologies that cause what we call systemic inflammation. So you might be already familiarized with the term inflammation. If you ever missed a nail and hammer your finger, you know the symptoms of inflammation already. That is redness, is pain, it gets swollen. But when that is mostly local inflammation. The term systemic inflammation is when you have such a degree of inflammation that some of the chemical messengers hit the brain and they start developing some more systemic signs for the whole body. For instance, fever, that could be inappetence or anorexia, that could be depression, basically not feeling like getting out of the bed. Is everything you experience when you have a flu, or if you ever had COVID. Okay. So this is a more biological explanation of why that happens. I won't cover this. If you have questions, I can explain this after the class, but it's not the goal of this class today. But these are the symptoms, basically anorexia, lethargy, and they have decreased activity. We call this sickness behavior syndrome. It is a syndrome because it's several symptoms combined, and basically it's a group of behavior that sick animals have. Okay, they have decreased activity, they eat less, hence they produce less milk, and they have increased body temperature. So I did this study back in Ohio, where we were classifying cows in different groups. Basically, what you have in the y-axis is lying time, and on the x-axis you have days relative to calving. This could also be days in milk. It could be another term that will fit this axis as well, right? Because at 0 they are calving, so they are starting to produce milk. Cows that have a metabolic disease that is called ketosis. If you have any relative with diabetes, this is one complication that patients with diabetes have is ketosis. But anyways, it's a disease that we also have in cows after calving. And so cows that have ketosis plus any other disease is the blue line right here, and ND is non-disease cows. So I just want you to focus your attention to these two lines. And once again, you can see that when cows are very sick, so basically if they have ketosis and something else, and that other disease could be mastitis, that is a disease of the mammary gland, or it could be metritis, that is a disease of the uterus of the cow. You can see that they decrease their lying time, especially when these diseases are severe. This is a study that was done at Cornell. Basically, they were looking at this metabolic disease, ketosis, and other digestive diseases. And what you have here is two graphs. This one on the bottom right has the activity on the y-axis, and now this has days relative to clinical diagnosis. What this means is that at day 0, the farm personnel found these cows with the disease, okay? So you can see that the system here, it was detecting those cows with lower activity than cows that were non-sick already. The other line that you will find here, so non-disease will be this black line, and cows that were diseased is this line over here, but these are cows that were diseased and were detected as positive by the system. The third line, that is one with these gray filled circles, is cows that were sick, but the system detected them as not having a health event, okay? In short, you can see that cows that were accurately detected as sick and they did have the disease, they have decreased activity and rumination. And once again, they combine this information with an algorithm. And here they call it a health index score. And the take-home message from this study is that basically with this alarm system, they were able to detect cows that were sick 2 days before than the farm personnel, okay? And the sensitivity for detecting these diseases was quite good. It was 93% for digestive diseases and ketosis. However, it was quite bad for mastitis. It was not too good. The sensitivity was only 58%. And for mastitis caused by a bacteria, that is E. coli, it was 81%. And for mastitis caused by other type of bacteria that are from the gram-positive group, it was 45 to 48%. I have a question here, why this would be mostly for veterinarians, because they should know the answer. You don't need to know the answer, but basically the explanation for this and what is useful for you is that mastitis caused by E. coli are much more severe, or they express more severe symptoms than most mastitis caused by gram-positive bacteria. So the reason why it increased the sensitivity of the test is that by being more sensitive, cows have further increased their lying time, they have further decreased their steps. So all these sickness behavior are more expressed in these cows. Something similar happens to metritis. Again, metritis is the infection of the uterus, right? Or I'm sorry, the inflammation of the uterus. And mastitis is the inflammation of the mammary gland, mostly caused by bacterial infection. And the sensitivity is not great. And once again, it's not great for mild cases, but it's very good for severe cases. If you think about it, what happens is that when you have mild cases of metritis or mastitis, most of the inflammation is contained in the organ, is contained either in the mammary gland or is contained in the uterus. When it gets severe, all of these inflammation biomarkers, they get to the blood and they hit the brain. And when they get to the brain, they trigger changes in behavior, they trigger fever. And that's why those cows express more that sickness behavior, and that's why those cases have higher sensitivity. I don't know if this is too confusing for you guys, or I hope it's making sense. I know this is a lot of biological concepts, but that's why we see differences in sensitivities depending on the disease. So far, we talk about intrinsic factors, so cow level factors that could change behavior and how we can try to find them. And we have physiological factors. That means that basically they will occur normally in the absence of disease, such as when cows getting hit or when they are approaching calving, or pathological when they are sick. That can be a hoof disease, that they become lame, they struggle to walk, or when they have diseases, especially the ones that cause systemic inflammation, exacerbated systemic inflammation. But we can also use these technologies to assess extrinsic factors, okay? So basically, these are herd level factors, and these are changes in management that we do. For instance, if we do changes in facility design or maintenance, if we change if you will, the bed of the cow and the maintenance of that bedding, the design of that bed where the cow is lying down, or the design and the amount of equipment that we use to dissipate heat of cows. So that is fans, that is sprinklers, shades. We can see changes in behavior as well. And I will explain in a little bit why we see those changes. From herd management practices as well, if we do a lot of group or regrouping, cows have hierarchically arranged the groups socially. So when we change animals in a group, we see some changes in behavior. Stocking density, if we put too many cows in a pen that they compete more, we will also see changes in behavior. Or if we restrain cows for a lot of time, obviously we will see decreased lying time as well. So what is the value of this? Why do we care? So take bedding frequency. This is a study basically that was measuring how much sand cows were losing in the bed, and the darker the color at the center of the bed, the more sand they were losing. So basically here you have this dark black will be when they were losing 4 inches of sand at the center of the bed compared to the rear curve of the bed on this concrete wall, okay? And the reason why this matters is that for every inch loss below the rear curve, line time will decrease half an hour. So after 1 week, this study found that cows had a mean loss of 2.5 inches and a maximum loss of 6 inches. So that is huge. 3 hours of line time lost in dairy farms is too much, and is something we try to prevent. Why? Because it can lead to more hoof issues. It can lead to decreased production. Cows produce more milk when they are lying down because the blood flow of the mammary gland is higher when they are lying down. Now, with regards not to the quantity, but the quality of the bedding, this graph, what is showing is lying time on the y-axis, and it has 2 different type of bedding, right? So this is dry sawdust or wet sawdust. Basically, this one has 74% humidity, so 26% dry matter, so it's very wet. And you can see that it decreased line time by 5 hours. And again, we worry about line time a lot because it's important to have cow comfort, to keep the cows hoof healthy, and to keep good milk production and reproductive performance. Heat abatement, bear with me with this graph because it's quite complicated, but I will walk you through the graph. Basically, what you have, this line is showing body temperature of the cows, and the orange line is showing when they were either lying down or standing. So when the bar goes up here is a standing bout, and then when it goes down is a lying bout, is when they are lying down, okay? So the pattern that you will notice here is that anytime a cow lays down, she's increasing her body temperature. As you see here, that is rising. Then when she stands up, she can dissipate body temperature better. And the cycle repeat. Again, she lays down, then she starts building body temperature, it starts increasing up to a point that she's uncomfortable, so she stands up and starts losing that body temperature, okay? The other parameters that you can see here show the same concept. So basically, these squares are respiration rate. When cows increase their body temperature, they try to dissipate that heat, and that's why they increase their respiratory rate, but it's showing the same. Basically, you see that anytime they are lying down, they are increasing their respiratory rate, okay? So all of this strongly proves that cows that are heat stressed, they have decreased line time, and because they are trying to dissipate that heat. And we explained already why we try to maximize line time in cows, why that is so important. This is my second to last slide, but basically we have also some herd management practices, and this is a study we did with Sushil. That basically this herd went from locking cows for over 2 hours a day, and consider that they also spend 3 hours at when they go to the milking parlor, either waiting to be milked or at the milking parlor. They spend roughly 45 to 1 hour each time, and they go 3 times a day. So all in all, this will lead to a total restrainment of 5 hours, okay? And that is the control group. And the treatment group is when they stop locking up cows at the pen. I mean, of course, they were still milking these cows, but they were not locked up for 2 hours a day. And basically, they saw increased milk production. This is what this is showing. So basically, they have a first, second, third, and fourth monthly test of milk production, and this is in pounds. For reproductive performance, again, when they, this is the same study, but basically when they stop locking cows, they will become pregnant earlier. So this is the treatment. This was the group of cows that were not locked at the headlock. Especially the cows. This study was done with cows after calving. That this is a very important group because it's a very sensitive group. The cows after calving is where we want to improve the time badges of cows the most and make sure that they are having enough line time and enough eating time. But anyways, you can see the not only statistically significant, but also tremendous effect size difference between the treatment and the control, decreasing the days to pregnancy. In regards to health, it also decreased lameness incidence almost by 1/3, and mastitis incidence, it was a tremendous effect that the treatment had as well. So with that, I will stop sharing my screen and I will take any questions that you guys may have. Hopefully I didn't bore you to death.
I think that was awesome. I think that was a step up from what we discussed in my talk. And I think it's rather than a question. I think I want you to comment like maybe two things, basically from your experience on the field. So what I think it's a curiosity out of all students as well. What is the most common technology that you see been applied in the field right now in the dairy farms, and do you see it booming? So do you see it coming like in a rapid pace, or how soon, how common is it now? Are the producers adopting this technology, or what do you see in the field and the application on the farms?
So this is empirical knowledge. Not I haven't done a survey, but
Yeah.
My experience from the dairy farmers that I work with in Ohio and other places is that in the past they used mostly leg-based technologies, and now I'm seeing more dairy farms that they were not using any precision technology, but they don't go to leg-based anymore. They are using more collars and ear-based. Then the next question will be why. And I think if you think about it, leg-based technologies, they will have a 3D accelerometer so they can measure activity. But if you use a collar, they have other type of technologies to also measure rumination. I believe they track the sound of the bolus when it goes from the rumen through the esophagus to the mouth, for the cow to regurgitate, chew again, and swallow again. So I think that is one reason why they use it. Of course, when you have more parameters, you can have detect more events and also have more accuracy on the events that you are detecting, if you are assessing those parameters correctly, of course. With the ear, and that's bringing me to the ear-based technologies. Ear-based, I don't have a lot of experience. They look quite interesting. They measure feeding time, rumination time, depending on the technology, right? There are some that's only measure temperature, but the ones that measure most things, they will measure eating time, rumination time, and temperature. And activity. Now the problem with that is that you start, a lot of people are skeptical about how accurate they are because they are based on error movements. So basically they are basing from error movements the eating time. So it should have a different pattern of ear movements from the rumination time and the activity and the temperature. So that's where I see that some scientists are a little bit skeptical about that, and I don't have a lot of data with that. Sushil, I think you did more work with ear-based technologies, but I'm seeing a lot of collars nowadays being used more than anything. That's the main wearable precision technology that I'm seeing nowadays.
And I think that's exactly what I was going as well. So we're seeing a lot of that in this part of the kind of Texas as well. One thing I think what I wanted you to thought space again before I open it up to students is I think we discussed about some benefits of this, but one thing that's driving this, like, do you see like my communication with the producers? I see that labor force, basically all this technology, they are able to reduce the labor, reduce the time a person needed to work on the dairy farms. And with this labor market, with this scarcity of labor, that's one reason a lot of the producers are going and adopting or buying new technology into the farms. And now in there you talk about like milking, like new robotic milking coming along with these sensors. So do you see that as well, or there are some other reasons you see producers are going after this technology?
Absolutely, labor is at the top of the list. And as you mentioned, not only the automation on these precision technologies to find cows that are either in heat or sick, but also, as you mentioned, some other technologies such as automatic milking robots, so they don't have to have milkers to milk cows. Now they go to a robot, or automatic feed pushers, and you don't need an employee pushing the feed. Now they have these robots to do that. And we're also seeing automatic cow feeders. Instead of preparing the milk for the cows and putting the bottle and then cleaning the bottle, there are some robots basically that can feed several calves. So that's number one. The second one that perhaps is not that often, but we also see it is when they are not happy with the performance of the breeders, and basically with this technology, they get a reliable assessment of cows that are becoming in heat. They need to be on top of the technology in the sense that it has to work. And I have worked at dairies sometimes that they have some colors with maybe 5% of the colors not working. That is too much. You need to be changing those technologies. When that starts happening, they use a combination of methods. So they are using the colors, but because they don't trust the colors, or because they have 5 that don't work anymore or are malfunctioning, they are using another method. In cows, what we do is we paint the tails, and since cows in heat have this behavior that they mount each other, when they mount each other, they remove the tail. But that is adding more work, and that, I mean, if you're investing in the technology, you shouldn't be doing that. You should be trusting the technology and making sure that all the equipment that you have works properly. So in that case, you should just replace those 5% of colors that are not working for ones that will be working properly.
I have one. Thank you for the presentation, Dr. Pinero. It was really good kind of follow-up of what Cecil kind of gave a general perspective of how precision dairy management is going on and how actually it has been utilized. So I was kind of curious. I think Cecil also asked that question that I was what is the adaptability, but at the same time, how easy it is to use those kind of color sensors or whatever sensors. Is it like, are there some apps that come along with them so that the farmers can, how do they really work? Is it on just the data collection side, or is it on really visualizing what is going on and, oh, okay, this cow is sick, like with certain ID number, this cow is sick. How does that really circulate along? Like from collecting the data to transferring the data, and then maybe the farmer can really see how it has been done. That is what I wanted to know your experience.
Yeah. So most of these companies, they have to remain competitive, right? So they try to make it very easy and very user friendly. So let's take example of one colors that will measure activity. The way it would work is we will bring cows to a headlock where we can restrain them, and we will put collars to all of those cows. And then there are antennas basically that will receive this signal, or readers that can be at different parts of the dairy. For this collar that I was working, I think the antenna was receiving constantly, or every 15 minutes was receiving information. Some other ones have a different system that they will read once they go to the milking parlor, especially some ear-based technologies, when the head is close to a metal structure. But most of them have an antenna. And from that antenna, the information is received. It goes to the software that is in a computer. In the computer, this software basically has these algorithms that combine different parameters, and they give flags, alarm system. And most frequently, you will see an alarm system for cows that are in heat, and an alarm system for cows that might be getting sick. For the former, it will be increased activity and perhaps decrease eating time. For decreased eating time. And for cows that are getting sick, it's also decreased eating time, but it will be also decreased activity. So that's how they can sort them out. And once you have those cows flagged, also what they may have is something we call sorting gates. So what that is when we bring cows to be milked at the milking parlor, some days what they have on the alleyway that they walk to go back to the pens, they have a reader for an ID that they have on the ear that is called RFID. RFID comes from radio frequency identification. So you can put on the software, okay, I want cows number 100 to be sorted because she was flagged sick or she was flagged as being in heat. So then the sorting gate will open and it will take her to a management pen. And then you don't have to go to the pen and look for the cow because she's on that smaller pen or on that chute. And if she was flagged to be sick, you can do a clinical examination and then treat her. And if she was flagged to be in heat, you can basically prepare the semen and the breeding gun and just breed her.
Oh. Maybe the students, do you have any questions?
Yeah, but in summary, that they are very user friendly, and they have to, because if not, they cannot remain competitive.
I think I really like the idea of how that separation goes into place once the alarm is there for different events, you know. That is quite interesting.
So I would like to learn a little bit about you all guys. What are you saying? I know Kim is in animal science, but how about the rest of you? In which department are you?
Yeah, let's hear from everybody. So let's let's hear. Tell us your name, where, what university you are from, and maybe tell us about. I have been getting quite a few like midterm, but like maybe tell us about this program, how you are liking it, and what do you get from here, or what getting from this program or this session as a whole as well. So yeah, let's do that. That's a perfect timing one. So
can you stop sharing? I think we are looking at our own.
yeah, so if you can stop sharing your screen.
Yes, sorry.
Yeah, that would be easier. Yeah, so feel free to unmute yourself and maybe open up your camera so that we can see you. I'll be honest with you, we have been doing this session for some time and I may not have seen a couple of students yet. So I would like to see your face as well, if possible. That's the case. So any volunteers? I can go with the list I have in the random order. Okay, I'll go with the list. So my top of the list is Danilia. So if you can unmute yourself and yeah, briefly tell us about yourself.
So, hi everyone. My name is Daniela. I go to school in Texas A&M University at Kingsville. I'm studying agriculture education with a minor in sociology. What was the next question?
Okay, so how is your experience so far in the course, and also what do you like about today's session?
Um, this process of this internship has been very interesting. I do have a little bit background in animal science, so I can kind of understand a little bit more. Um, Today's presentation was very interesting. I really liked it. It went back to the first presentation that we learned the first day of the second day of this internship. And it was really nice looking at data that you were presenting and putting it together and seeing new ways that we can use this information. Thank you.
Okay. Yeah, thank you. I think second on my list is Jack.
How's it going? I'm Jack Dutton. I'm from Texas A&M University at College Station. I'm studying animal science there, and my group actually has the animal science data that we're using, and it is dairy data, and so today was very useful for that. Building off of Dr. Suchel's talk on the second day of the internship, that was extremely useful on that, and I'm glad that my group was able to come today and that we were able to listen in on this talk, because I think this answers a lot of questions that we were having when we were working on it. So,
Excellent, fantastic.
Are you doing practicing small animal practice? Because I see some.
Yeah, I'm in a mixed animal practice right now, but this is our small animal warden. So, yeah, that's where I'm at right now.
Good. So you plan to go to vet school?
I hope so. Yes, sir. I'm applying this summer. So
awesome. Well, good luck.
Thank you. Thank you.
Okay. And I think our next on my list is Sam. Sam Dahl.
Hi. Yes, so am I audible?
Yeah.
So this is Sambandh, and I'm a PhD student in the Department of Computer Engineering at Texas A&M College Station. So I am an intern under Dr. Bhandari here at the center. And so until now, the experience has been pretty nice. It is great to see students learn basics about data science and do some hands-on coding on database and some practical machine learning models, some analysis. Although it is a very small time to catch up on a lot of topics, but yes, it is a great effort on your part and Dr. Vandari's part to see that students can make the best use of the summer and have some basic knowledge about how to analyze data. And regarding today's lecture, it was mostly based on livestock and like animal science. Although I am not familiar to the background, it was good to hear that. Thank you, sir.
Yeah, no worries. Thank you. I think that's how we learn, right? So I think next on my list is Anna.
Hello, my name is Anna. I attend Texas A&M University, Corpus Christi. I major in geographic information sciences with a minor in mathematics. Pretty much everything in today's meeting has been either new or been able to kind of embellish with the little I have already learned. I'm part of the dairy science group, and so everything was useful. I'm just really pleased to have learned so much.
Right. Thanks, Anna. I think next on my list is Hers. Let's hear from Hers.
Hi, hello. Myself Harsha. I'm from Tamuk, Kingsville. I'm doing my major in plant and soil science. So I joined lately to this project, but I went to all the recordings which have been done previously, and I'm learning something about the data integration and data analysis. So at present, I'm working with Dr. Mahendra. I'm doing data analysis and data processing in Texas A&M. So that's all for now from my side. And today's topic, like in today's topic, I had learned like about mostly about the graph which was shown by Horn, like the standing and sitting position of the cow changes the milking period. So I know about that somehow, but not that in detail. But I came to know that how it happens and how it does work. Yeah, thank you.
Yeah, thank you, Harsha. I think next on my list is Esther Kim.
Hello. Not sure why my camera's not working, but anyways, yeah, I'm animal science, as Dr. Pinheiro said. And for me, this internship, it's been really fun. I like that we can still get this quality information and presentations from the ease of just home. And oh, I forgot to say, I'm from A&M College Station. And yeah, I think the information is really interesting, coming from me, who had no ag background at all before going to college. And then now I'm learning about all this animal science and dairy science. And in this internship, plant science information as well. I think it's really just interactive and fun. And I've been really enjoying it this summer.
Perfect. Thank you. And I think we have Sindhu.
Hello everyone. I'm doing my master's in Texas A&M Kingsville, and currently I'm working for Mahindra. So I'm with the animal science data and the animal science group. So in my undergrad, I only took one class. So it's like a challenging for me to learn more about the things that I don't know. And Jack is helping us a lot. And that's like today's presentation is very nice. I mean, we got to learn a lot of new things, and the graphs are so pretty. I want to know more about them, and yeah, that's it. Thank you.
Perfect. And I think we have Papus. He has been helping us for the data and everything. So yeah, if Papus is here, if you can tell us more about your experience.
Hi everyone. So my name is Tapas and I'm a current master student. I'm a computer science student. With my minor is data engineering and my major is computer science. And currently I'm an intern and I'm working under Dr. Bhandari. And it's really a good informative session. So like the way you are showing those like the data analysis part, like how when the sick period is happening, how the data is showing, from the data we can denote that what exactly is happening over there. And probably though that is a key parameter for doing a prediction kind of thing. Like maybe we can I think like maybe you're doing that. So that's a kind of the machine learning things can be done over there. And it's really gave us a very kind of very good picture what's how the animal science is working, how the animal data is collected, how the sensors are working. It's really a very nice session, and I really learned a lot of things from here. So yeah, thank you so much, sir.
Well, yeah, I think that's all. I think any announcement, Dr. Bhandari?
I just wanted to see if the group leaders can give us a brief about what they are feeling about the data and how that is coming along, and maybe what kind of help they need, if they need a little bit of demonstration from the experts or anything like that, then I think that will be good. So from plant science, who is the group leader from plant science? Is it Daniel, I think, right?
Yes. So our process has been, we've been, I want to say slow baby steps, you know. We're all not computer science, we're two plant science and one animal science major. But we're making progress. I think one thing that we talked about is more of like, where do you want us to lead into this to get what data you want us to like, get out of it. Because y'all said it was an open objective, like whatever we see connect. So I think that's what's gonna be our next step, is seeing what we can do. But if y'all have more information to give us in ways that we can kind of find a narrow line to help us get a good start to figure out what data we want to pull out of it.
And one of the discussions that we had with Daniela here was the group was unable to transfer the data from the Excel sheet to MySQL. Were you able to do that in both of the groups, or you need help on that side?
I was able to extract the Excel file and put it into my the software, thanks to Dr. Lucy, and then the additional help with one of the people that work here in the AgroLife Center. So, and Anna also, we came together and they helped me figure it out and put all the Excel sheets into one.
Right. What about the animal science group? I think is the leader Anna, or anyone, if you can share your experience with the data, and maybe if there is somewhere that you might need help, then please let us know. Anna, you want Anna or Jack? I think maybe one of you guys can give a brief update on how your data-based work is going on.
So we haven't put it into the software yet. We spent all of our time classifying variables and trying to build connections between them and try to develop our flowchart. But we haven't done anything in regards to software yet. But we've gotten pretty far on actually trying to establish relationships between the variables.
Yeah, I think that's excellent. I think that's the first step, and I know Jack had gotten back to me with questions on the data set, and like I mentioned, if you have a confusion, if you need me anywhere, just send me an email, and I would love to jump into your sessions or maybe explain anything that would be helpful for you during that session as well. So yeah, feel free to send us an email and seek help if you need any resources. Okay, with that, I think we have almost come to the end of the session. Thanks again, Dr. Juan Pinero, for joining us from Amarillo. And for all students, if you have not submitted your midterm survey, please send that to me. I have a couple of students already send that to me, but if you have not, send that to me, please do so. It's a small form. It's a 2-page survey, so it's not any big. So we just want to see where you are, or any help that you need from us, or if you could make any modifications on the project to help you learn better from the internship. I think that would be our goal. So please do so whenever you have some time.
Thank you. I had a great time. Sushil, do the students need the slides for studying? Do they have a test? Do you want me to send you a PDF of the slides?
Yeah, we don't have a test, but if you can send that to me, we have a website where we deposit put all our slides and stuff. That would be helpful for the resources. So yeah, I think that would be helpful if you send that to me.
Yeah, and if they have any questions from my presentation, they can send me an email. I'll be happy to help.
Sounds good. So any final thoughts, questions, concerns? Okay, if not, I think we will close the session here. Thank you all for joining again. And yeah, it's hot outside. Stay cool, stay hydrated, and take care. So we'll see you again next week. I think next week is going to be more fun with data, right? So Dr. Fonari, I think it's going to be yeah, more on data science.
Yeah, on basics on artificial intelligence and machine learning.
Okay, I'm excited. So thank
Are
you.
you saying that today was not fun, Sushil?
No, it's
I'm just messing around.
Okay, sounds good. Thank you all. Thank you very much.
Bye-bye.
Bye. Have a nice evening.